Hello, everybody. Tonight I want to talk about something that might keep you awake for just a moment before it helps you drift off to sleep. It's a question that sounds simple, but opens up into something beautifully complex and unsettling. Are we actually the first civilization on Earth? Not the first humans to build cities or invent writing, but the first intelligent beings to ever call this planet home. I know what you're thinking. This sounds like the setup to some wild conspiracy theory or ancient aliens documentary. But here's the thing. This is actually a legitimate scientific question that researchers have been quietly exploring in geology labs and academic conferences. And it's not about finding alien spacecraft buried in coal mines or discovering laser guns in limestone. It's something far more subtle and far more fascinating. The question isn't whether we'll stumble across some ancient iPhone fossilized in million-year-old rock. It's whether we could even tell if someone came before us, whether the slow, relentless grinding of geological time would have erased every trace of their existence, leaving behind a planet that looks entirely natural, entirely untouched by intelligence. There's something oddly comforting about the fact that no matter where or when you are, we're sharing the same moment of curiosity about deep time. So settle in and let your mind slow down to the pace of continents drifting. We're going to take a journey not through human history, but through something much deeper and stranger. We're going to explore the possibility that intelligence isn't as rare as we think, and that our planet might be keeping secrets we never thought to ask about. When we think about ancient history, our minds usually go to familiar places. The pyramids of Egypt, the stone circles of ancient Britain, maybe the first cave paintings or the earliest written languages. But even when we reach back to what feels like the dawn of civilization, we're still only looking at about 12,000 years. That's agriculture. That's the beginning of permanent settlements and complex societies. 12,000 years sounds like an impossibly long time when you're living through it day by day. But in geological terms, it's barely a whisper. It's closer to right now than it is to almost anything else that's ever happened on this planet. And that's where things start to get interesting. Because Earth isn't 12,000 years old. It's not even 12 million years old. Our planet has been spinning through space for roughly 4.5 billion years. Let me put that in perspective for you. If Earth's entire history was compressed into a single year, human civilization would occupy the last few minutes before midnight on December 31st. We've been here for such a brief moment that we barely register on the planetary timeline. For the vast majority of Earth's existence, there were no humans at all. For most of it, there weren't even mammals. And for enormous stretches of time, there was no complex life on land whatsoever. Life spent billions of years swimming, waiting, evolving in microscopic obscurity. Yet during all that seemingly empty time, most of Earth's story was being written layer by layer, rock by rock. Here's what makes this question so fascinating and so difficult. The planet doesn't keep a journal. It doesn't preserve everything equally or fairly. Wood rots away. Metal rusts into nothing. Bones dissolve in acid soil. And time doesn't just pass. It actively works against preservation. It buries things under sediment. It melts them in volcanic heat. It crushes them under the weight of new mountains. It stretches and folds and breaks them apart. Every few 100 million years, the entire face of the world changes completely. Continents drift apart and crash back together. Mountains rise from flat plains and then crumble back to dust. Oceans open up where there used to be dry land. What was once a thriving coastline might now be buried miles underground, or it might have been dragged down into the Earth's interior and melted back into molten rock. When you really think about it, it's not that evidence gets lost over time. It's that surviving anything at all for more than a few million years is already an extraordinary achievement against impossible odds. The default state isn't preservation, it's erasure. So let's try a thought experiment. Imagine that 100 million years ago, long after the dinosaurs had established their dominance, but long before they disappeared, something developed intelligence. Maybe it was reptilian. Maybe it was something else entirely. Maybe it never needed to build with stone or metal. Maybe it had technology we wouldn't even recognize as technology. Maybe this hypothetical civilization lived sustainably, in harmony with their environment, for thousands, or even tens of thousands of years. Maybe they developed art, philosophy, even science. Maybe they mapped the stars and understood the seasons and created beautiful things that brought meaning to their lives. And then maybe something happened. A climate shift, a natural disaster, or simply the slow passage of time. They faded away. Now fast forward to today. We arrive millions upon millions of years later with our shovels and our scientific instruments, asking whether anyone was here before us. Would we even know? Would there be anything left to find? The hard truth is that we're not nearly as permanent as we like to believe. Our skyscrapers, our highways, our entire digital civilization, none of it is built to survive geological time, leave a modern city completely alone for just a few centuries, and nature starts to reclaim it. Roots push through concrete. Weather erodes steel and glass. In a few thousand years, it becomes difficult to see what was once there. But stretch that timeline to a few million years, and erosion, plate tectonics, and the constant recycling of the Earth's surface would have done their work. Most of our traces would be gone. What was once land might now be ocean floor. What was once a mountain might be scattered as sediment across the bottom of the sea. This isn't science fiction speculation. It's based on what we actually know from studying geology and archaeology. Even traces of recent prehistoric human activity are incredibly rare to find. Not because our ancestors didn't do interesting things, but because Earth is remarkably efficient at recycling everything back into itself. Consider the fossil record that we use to understand ancient life, and it's incredibly spotty and incomplete. Not because life wasn't abundant in the past, but because the conditions needed for fossilization are very specific and very rare. Most living things that die are never fossilized. They decompose, get eaten, or simply dissolve away. To become a fossil, you need rapid burial, the right kind of sediment, protection from erosion, and then you need to get incredibly lucky. The rock containing your remains has to survive for millions of years without being crushed, melted, or worn away. Then it has to be exposed at just the right moment, when someone happens to be looking in just the right place. Multiply that challenge by tens of millions of years, and you start to see the scale of the problem. If preserving bones, which are literally parts of living organisms, is this difficult, imagine trying to preserve buildings, tools, art, or technology. Most metals corrode away completely. Most materials break down, to sunlight, especially when exposed to water or the slow chemistry of soil. Even concrete, which seems so solid and permanent, eventually crumbles when left without maintenance. So if a civilization had existed in the deep past, especially one that built primarily with organic materials, or didn't leave behind massive stone monuments, we might never have any way of knowing they were here. You might wonder whether anyone has seriously considered this possibility. The answer is yes. In 2018, two scientists named Gavin Schmidt and Adam Frank published a research paper exploring exactly this question. They weren't claiming that such a civilization actually existed, but they were asking a methodological question that cuts right to the heart of scientific thinking. If an industrial civilization similar to ours had existed 50 or even 100 million years ago, and then vanished completely, what kinds of traces might it have left behind? And more importantly, would we be able to recognize those traces for what they were? Or would we interpret them as something entirely natural? They called their thought experiment the Silurian hypothesis, borrowing the name from a science fiction television show. But their question was completely serious and scientifically rigorous. What would you actually look for if you wanted to detect the remains of a vanished technological civilization? Their approach was fascinating because it forced scientists to think like planetary detectives working a cold case from millions of years ago. Instead of looking for obvious artifacts like buildings or machines, they focused on what they called chemical fingerprints, the kinds of changes that industrial activity leaves behind in the chemistry of rocks, sediments, and ice cores. Think about what our own civilization is doing right now. We're pumping carbon dioxide into the atmosphere at unprecedented rates. We're scattering synthetic chemicals across every continent and ocean. We're creating entirely new materials that have never existed in nature before. Plastics, industrial metals, radioactive isotopes from nuclear testing. All of these leave distinct chemical signatures that are being written into the geological record as we speak. If someone looked at rock layers from our time millions of years in the future, they'd see clear evidence that something unusual was happening. Sharp spikes in atmospheric carbon, strange polymers embedded in sediment, isotope ratios that don't match any known natural process. Our industrial fingerprint would be unmistakable, at least for a while. But here's where it gets tricky. Many of the same chemical signals that industrial civilization produces can also be created by natural processes. Massive volcanic eruptions can pump carbon dioxide into the atmosphere and cause rapid climate change. Natural forest fires can leave behind layers of charcoal and ash. Even some synthetic-looking materials can form under extreme geological conditions. So the challenge isn't just finding unusual chemistry in ancient rocks. It's figuring out whether that chemistry points to intelligence or just to the planet doing what planets naturally do. And when you're looking at events that happened tens of millions of years ago, that distinction can be almost impossible to make. This is what makes the search for ancient civilizations so different from archaeology as we normally think of it. Archaeologists studying human cultures can usually find pottery shards, stone tools, or the foundations of buildings. They have context. They can see patterns that clearly indicate deliberate human activity. But if you're looking for evidence of intelligence from the deep past, you have to think more like a climate scientist or a geochemist. You're not looking for artifacts. You're looking for disruptions in the normal patterns of how the planet behaves, sudden changes in ocean chemistry, unusual concentrations of rare elements, extinction events that don't have obvious natural causes. The problem is that even if you found these kinds of signals, proving they came from intelligence rather than natural processes would require extraordinary evidence. And extraordinary evidence is exactly what geological time is designed to destroy. Let's think about what would happen if our own civilization vanished tomorrow. Not through some dramatic apocalypse, but simply if every human being disappeared overnight. How long would it take for our traces to fade away? In the first few years, our cities would still be recognizable. Buildings would stand, roads would be visible, our satellites would still be orbiting overhead. But without constant maintenance, Everything would start to break down surprisingly quickly. Plants would begin growing through cracks in pavement. Weather would start wearing away at exposed surfaces. After a few decades, many structures would be collapsing. Steel rusts when it's not protected. Concrete develops cracks that let in water, and water freezes and expands, breaking things apart from the inside. Vegetation would be reclaiming urban areas, and in many places you'd have to look carefully to see that cities had ever been there at all. Jump ahead 1,000 years, and most surface traces of our civilization would be gone or deeply buried. Only the most durable materials would survive, and even those would be scattered and broken. Stone monuments might persist in dry climates. Some underground structures might remain intact, but the vast majority of what we think of as permanent would have vanished into the slow recycling systems of the planet. Stretch that timeline to 1,000,000 years, and you're looking at something entirely different. Erosion would have worn down most remaining structures. Plate tectonics might have shifted the continents. Climate changes would have altered coastlines and river systems. What little remained would be buried so deep under accumulated sediment that finding it would be like looking for a needle in a haystack, the size of a continent. Yet even after 1,000,000 years, some traces might persist. Not our buildings or our machines, but our chemistry, the carbon we've released into the atmosphere, the synthetic materials we've scattered everywhere, the isotopes from nuclear testing. These chemical signatures are already being incorporated into sediment layers and ice cores around the world. Future geologists might find a thin band in the rock record where carbon isotope ratios suddenly shift, where traces of artificial materials first appear, where the diversity of life takes a sharp downturn. They might not know what caused these changes, but they'd know something significant happened. This is exactly the kind of evidence that researchers like Schmidt and Frank suggest we should be looking for when we ask about earlier civilizations, not ruins or artifacts, but chemical anomalies, geological layers where the normal patterns get disrupted in ways that might possibly indicate the presence of intelligence. And here's what makes this both exciting and frustrating. We've actually found plenty of these kinds of anomalies in the geological record. Sharp changes in atmospheric chemistry, mass extinction events, periods where the planet's carbon cycle goes haywire for reasons that aren't entirely clear. Most of these events have perfectly reasonable natural explanations: massive volcanic eruptions, asteroid impacts, sudden releases of methane from the ocean floor. The planet has its own ways of dramatically altering its chemistry without any help from intelligence. But a few of these ancient disruptions remain puzzling. There are extinction events that don't have obvious causes. There are chemical signatures that don't quite match the patterns we'd expect from known natural processes. There are isotope ratios that seem to tell a story we don't fully understand. Now, before you get too excited, let me be clear. None of these anomalies require intelligence to explain them. Scientists haven't found anything that can only be accounted for by proposing an ancient civilization. But they have found things that make you wonder, things that leave room for questions. And maybe that's enough for now. Maybe the point isn't to solve this mystery definitively, but to appreciate just how much we don't know about the deep history of our own planet, to recognize that the absence of evidence isn't always evidence of absence, especially when you're dealing with timescales that can erase mountains and turn entire oceans into desert. The Earth is old in ways that are hard to truly grasp. It has had time for countless experiments, countless possibilities, countless stories that began and ended long before our species even existed. Whether any of those stories involved intelligence, We may never know for certain. But as you drift off to sleep tonight, maybe you can find some comfort in that uncertainty, in the vast, quiet mystery of deep time, where so much has happened and so little has been preserved, where the planet keeps its secrets not out of malice, but simply because that's what time does. It moves forward, it covers things over, and it gives the world permission to begin again. The more you think about these questions, the more you realize that we might be looking for the wrong things entirely. We search for civilizations that look like us, that build like us, that leave behind the kinds of traces we would leave behind. But intelligence doesn't have to follow our template. It doesn't have to be obsessed with permanence or monuments or leaving its mark on the world. Consider the possibility that a previous civilization developed along entirely different lines. Maybe they never discovered metallurgy at all. Maybe they built everything from organic materials, wood and plant fibers, and cleverly shaped stone that required no mining, no smelting, no industrial processes that would leave chemical fingerprints in the rock record. Think about how many human cultures have lived this way. Indigenous societies that created sophisticated technologies from bamboo and bone and carefully cultivated plants. Civilizations that developed complex astronomical knowledge without ever needing to build massive stone observatories. Cultures that passed down incredibly detailed information through oral traditions that could preserve knowledge for thousands of years without ever writing it down. Now imagine scaling that up. A species that developed intelligence, but chose a completely different relationship with their environment. Maybe they were primarily aquatic, building their cities in coastal areas that are now deep underwater. Maybe they were nomadic, following migration patterns that left no permanent settlements. Maybe they were so perfectly adapted to their ecosystem that their presence enhanced rather than disrupted the natural world. If such a civilization had existed, what would we expect to find? The answer might be nothing at all, at least nothing we'd recognize as artificial. Their tools would have rotted away millions of years ago. Their buildings, if they built any, would have been reclaimed by forests and eroded by rivers. Their knowledge would have died with the last speaker of their language. But maybe, just maybe, they would have left behind something subtler. Changes in plant distribution patterns, unusual genetic diversity in certain species that suggest selective breeding or cultivation, soil compositions that don't quite match what you'd expect from natural processes, erosion patterns that seem too regular, too purposeful to be entirely accidental. The problem is that these kinds of traces are almost impossible to distinguish from natural variation. How do you prove that a particular grove of trees was planted rather than naturally seeded? How do you demonstrate that a river changed course because of intelligent intervention rather than normal geological processes? Even when we find things that seem unusual, our scientific training pushes us toward natural explanations first. And that's usually the right approach. Nature is capable of producing incredibly complex and seemingly purposeful patterns without any intelligence behind them. Crystalline structures that look almost architectural. Erosion features that create perfectly straight lines and right angles. Mineral deposits that seem too organized to be random. This is why the search for ancient intelligence requires such careful thinking. You can't just point to something weird and declare it artificial. You need multiple lines of evidence. You need patterns that repeat across different locations. You need chemical or physical signatures that genuinely can't be explained by known natural processes. And even then, you need to be honest about the limitations of your evidence. Science works by building the strongest case possible for the simplest explanation that fits the data. Proposing intelligence as an explanation for ancient anomalies is never the simplest option available. But here's what keeps this question alive despite all these challenges. Every so often, researchers do find things that don't fit neatly into our understanding of the past. Unusual isotope ratios in sediment cores that seem to spike and then return to normal without obvious cause. Extinction patterns that don't match typical climate or asteroid scenarios. Genetic markers in modern species that suggest bottlenecks or expansions that happened at unexpected times. Most of these anomalies eventually get explained through natural processes we hadn't considered before. New research reveals previously unknown volcanic activity, or climate cycles, or ecological dynamics that account for the strange data. But a few remain puzzling, sitting quietly in the scientific literature as unexplained observations. It's possible that some of these unexplained observations are exactly what we'd expect to find if intelligence had emerged and disappeared in the deep past. Not dramatic evidence, not obvious artifacts, but subtle disruptions in the planet's normal patterns. Chemical signatures that look almost natural but not quite. Biological changes that seem purposeful but lack clear environmental triggers. Or maybe these anomalies are just what they appear to be, natural variations in a complex planetary system that we don't fully understand yet. Maybe the patterns we think we see are just the human tendency to find meaning in randomness, to see faces in clouds and messages in noise. The truth is that we may never be able to definitively answer this question. The timescales involved are so vast, and the processes of geological change so thorough, that proving the existence of ancient intelligence might be impossible, even if such intelligence actually existed. And perhaps that's okay. Perhaps the value of asking this question isn't in finding a definitive answer, but in stretching our imagination about what's possible, in recognizing how much of Earth's history remains mysterious to us, in appreciating just how brief our own presence on this planet has been, and how temporary it might turn out to be. When you look up at the night sky, you're seeing light that left distant stars years or decades or centuries ago. You're looking into the past, seeing the universe as it was, not as it is now. In a similar way, when we dig into the Earth's layers, we're looking into deep time, trying to read stories written in stone and sediment and ice. But unlike starlight, which travels to us essentially unchanged across vast distances, the Earth's geological record has been edited and re-edited countless times. Pages have been torn out, written over, crumpled up, and smoothed out again. What we're left with is a fragmentary text with missing chapters and faded ink, trying to tell us about billions of years of planetary history. Reading this record requires not just scientific instruments and careful analysis, but also humility, the willingness to admit that there are things we don't know, patterns we haven't recognized, stories that may have been completely erased before we ever arrived to look for them. This humility doesn't mean abandoning scientific rigor or accepting wild speculation. It means staying curious about the unknown while being honest about the limits of what we can determine from the evidence available to us. It means being open to possibilities while maintaining healthy skepticism about extraordinary claims. As you settle deeper into sleep tonight, let your mind wander through these vast stretches of time. Imagine the Earth as it was millions of years ago, with different continents and different climates, and different forms of life experimenting with different ways of being intelligent. Maybe some of those experiments succeeded for a while, and then ended quietly, leaving behind only the faintest traces or no traces at all. Maybe intelligence is rarer than we think, a precious and fragile thing that emerged only recently with our own species. Or maybe it's more common than we imagine, blooming and fading like flowers in a garden we've only just begun to explore. Maybe we're the first, or maybe we're the latest in a long series of minds that have looked up at the same stars and wondered about their place in the cosmic story. The beautiful thing about this uncertainty is that it connects us to something larger than our immediate concerns. It reminds us that we're part of a story that began long before us and will continue long after we're gone. Whether that story includes other chapters of intelligence, we may never know for certain, but just asking the question changes how we see ourselves and our planet. It makes us more curious about the deep past and more thoughtful about the deep future. It encourages us to look more carefully at the world around us, to notice the subtle signs and patterns that might tell us something new about how intelligence emerges and persists and sometimes disappears. And maybe that's enough. Maybe the real value of this question isn't in the answer, but in the asking, in the way it opens our minds to possibilities we hadn't considered before, in the way it reminds us that mystery and wonder are still abundant in a world we sometimes think we've figured out completely. Sleep has a way of dissolving the boundaries between what we know and what we imagine. And as your mind begins to drift, maybe it's worth considering just how much the ocean has swallowed over the course of deep time. Because if there's one place where evidence of ancient civilizations would be most likely to disappear completely, it's beneath the waves. Most of the great cities in human history have been built near water. Rivers provide fresh water and transportation. Coastlines offer access to marine resources and trade routes. It's a practical choice that makes perfect sense for any intelligent species trying to establish complex societies. But it's also a choice that makes those societies incredibly vulnerable to the slow breathing of geological time. The thing about coastlines is that they're not permanent. They shift with tides and storms and the gradual rising and falling of sea levels. What we think of as solid ground is actually just the current position of a boundary that's been moving back and forth for millions of years. During ice ages, sea levels drop by hundreds of feet, exposing vast continental shelves that are normally underwater. When the ice melts, those same areas disappear beneath rising seas. Over the last 20,000 years alone, sea levels have risen more than 300 feet. Enormous areas that were once dry land, complete with rivers and forests and potentially habitable regions, are now buried under miles of ocean water and sediment. If any ancient civilization had built cities on those exposed continental shelves, they would now be completely inaccessible to us, hidden beneath layers of marine sediment and water, too deep for casual exploration. But even if we could somehow search every square mile of the ocean floor, what would we expect to find? The sea doesn't preserve things the way dry land sometimes does. Salt water is incredibly corrosive. It breaks down metals, dissolves bones, and reduces organic materials to nothing. Wave action batters anything near the surface. Deep currents slowly redistribute sediment, burying some things and exposing others to further erosion. Consider what happens to shipwrecks, which are much more recent than any hypothetical ancient civilization. Even ships that sank just a few centuries ago are often reduced to barely recognizable debris scattered across the seafloor. Wood gets eaten by marine organisms. Metal corrodes into unrecognizable lumps. Only in very specific conditions, like cold, deep water with low oxygen levels, do we find ships that retain their basic structure. Now imagine trying to preserve not just a single ship, but an entire coastal civilization for millions of years underwater. The mathematics of preservation become almost impossible. Everything would be broken apart, scattered, dissolved, or buried so deeply under accumulated sediment that detecting it would be like trying to find a specific grain of sand on a beach. There's also the issue of plate tectonics, which adds another layer of geological editing to the ocean floor. The seafloor isn't permanent like we tend to imagine. It's constantly being created at mid-ocean ridges and destroyed at subduction zones where oceanic plates dive beneath continental ones. This means that most of the ocean floor is actually quite young in geological terms, typically less than 200 million years old. Any evidence of ancient civilizations that ended up on oceanic plates would eventually be dragged down into the Earth's interior and melted back into magma. It wouldn't just be hidden, it would be completely recycled into the planet's internal circulation system. There would be no trace left to find, because the very foundation it rested on would have been consumed and reformed multiple times over. This process of oceanic recycling means that vast areas of the Earth's surface that existed in the distant past simply no longer exist in any recognizable form. Entire oceanic basins have opened and closed. Islands have appeared and disappeared. Coastlines have been completely redrawn by the slow dance of continents drifting across the planet's surface. If an ancient civilization had built floating cities or underwater habitats, if they had developed technologies that worked primarily in marine environments, if they had chosen to live in harmony with ocean currents and tidal cycles rather than fighting against them, almost every trace of their existence would have been erased by now. Not hidden, not buried, but actually destroyed at the molecular level and incorporated into new geological formations. The ocean also presents challenges for the kinds of indirect evidence that researchers look for when trying to detect ancient industrial activity. Chemical signatures get diluted in the vast volume of seawater. Synthetic materials get broken down by marine chemistry and biological processes. Even large-scale changes in ocean composition can be difficult to trace back to specific causes, especially when those causes occurred millions of years ago. Modern oceanography has revealed that the seas are much more dynamic than we once thought. Deep currents circulate water between ocean basins over periods of centuries. Upwelling brings deep water to the surface, mixing different chemical layers. Marine organisms constantly filter and process seawater, extracting some elements and concentrating others. All of this natural activity would tend to blur or erase the chemical fingerprints that an ancient civilization might have left behind. Yet despite all these challenges, the ocean does preserve some things remarkably well. Deep sea sediments can maintain detailed records of past climate conditions, volcanic eruptions, and even asteroid impacts. Cores drilled from the ocean floor provide some of our best evidence for understanding Earth's history over millions of years. The question is whether these sediment records might contain subtle traces of ancient intelligence that we simply haven't learned to recognize yet. Scientists have found unusual layers in marine sediments that don't have obvious natural explanations. Sudden spikes in certain metals, changes in isotope ratios that don't match known volcanic or climatic events, patterns of extinction and recovery that seem to follow unexpected timelines. Most of these anomalies eventually get explained through natural processes, but a few remain mysterious. It's possible that some of these unexplained features in the oceanic record represent exactly what we'd expect to find if an ancient civilization had once altered marine ecosystems or ocean chemistry. Not dramatic evidence, but subtle disruptions that persist in the sedimentary archive long after everything else has been erased. The challenge is distinguishing these potential signals from the enormous background of natural variation in ocean systems. Hydrothermal vents can release unusual concentrations of metals. Massive algae blooms can alter water chemistry. Underwater landslides can create distinctive sediment layers. Even changes in ocean circulation patterns can leave chemical signatures that might look artificial to someone who didn't understand their natural origin. This is where the search for ancient oceanic civilizations becomes as much about interpretation as it is about observation. You need not just unusual data, but a framework for understanding why that data might point toward intelligence rather than natural processes. And building that framework requires assumptions about how such a civilization might have behaved, what kinds of technologies they might have used, and what sorts of impacts they might have had on marine ecosystems. But maybe we're thinking about this wrong. Maybe the ocean's tendency to erase evidence isn't a limitation but a clue. Maybe the very fact that so much of Earth's surface gets recycled and renewed is exactly what would allow intelligence to emerge multiple times without leaving obvious traces. The planet has a built-in mechanism for wiping the slate clean, giving evolution fresh chances to experiment with consciousness and complexity. From this perspective, the ocean's role isn't just as a destroyer of evidence, but as a recycler of possibilities. Every subduction zone that melts ancient seafloor back into magma is also creating new oceanic crust that could someday support new forms of life. Every continental shelf that gets flooded during periods of sea level rise becomes a new frontier for marine ecosystems to explore. Perhaps intelligence isn't as rare as we think. Perhaps it emerges regularly on geological timescales, flourishes for a while in forms we might not even recognize, and then gets recycled back into the planet's ongoing experiments with complexity and awareness. The ocean, with its vast capacity for both preservation and destruction, might be the perfect laboratory for these kinds of experiments. As you drift deeper into sleep, imagine the sea floor as it might have been millions of years ago. Picture continental shelves that are now deep underwater, once dry and potentially habitable. Envision coastal regions that no longer exist, where rivers flowed into seas that have long since been transformed by the movement of continents. Maybe there were minds that watched those ancient sunsets, that wondered about their place in the cosmic order, that developed their own ways of understanding and shaping the world around them. Maybe they built cities that rose and fell with the tides. Maybe they developed technologies that worked with water rather than against it. Maybe they learned to live so lightly on the earth that their greatest achievement was leaving no permanent trace at all. The ocean keeps its secrets not out of malice, but out of necessity. It's a vast recycling system that maintains the planet's chemical balance, that regulates climate and weather patterns, that provides the conditions necessary for life to continue experimenting with new forms and possibilities. If it preserved everything perfectly, if it held onto every trace of past activity, it might become cluttered with the debris of previous experiments, unable to support new ones. Instead, the sea offers something more valuable than permanent preservation. It offers renewal. It offers the possibility that intelligence can emerge, explore its potential, and then gracefully fade away, leaving behind not monuments to its own importance, but opportunities for whatever comes next. This might be the ocean's greatest gift to consciousness, not the promise of immortality, but the assurance that nothing is truly final, that every ending creates space for new beginnings, that the story of intelligence on Earth might be much longer and more complex than we imagine, with chapters written in languages we're only just beginning to learn how to read. The rhythm of waves against the shore has been lulling minds to sleep for millions of years. Tonight, as that same rhythm carries you toward dreams, Maybe you can find comfort in the thought that you're part of something vast and ongoing, something that connects you, not just to other human minds, but to the deeper currents of consciousness that have been flowing through this planet for far longer than we've been here to notice them. The strangest thing about looking for traces of ancient intelligence isn't what we might find, but what we've already found and dismissed. Sitting in museums around the world, tucked away in storage rooms and filing cabinets, are thousands of objects that don't quite fit the story we tell ourselves about the past. Most of them have perfectly reasonable explanations, but some make you pause and wonder. There are polished stone spheres found in geological layers that seem too old for any known tool-making culture. Metal fragments embedded in coal seams that shouldn't contain anything artificial. Crystalline formations that look almost manufactured, with angles and symmetries that seem too precise to be natural. Rock formations with patterns that repeat in ways that make geologists scratch their heads and reach for natural explanations that don't quite satisfy. The thing is, nature is incredibly good at producing things that look artificial. Mineral crystals grow in perfect geometric shapes. Erosion can carve straight lines and right angles. Chemical processes can create layered structures that seem deliberately engineered. So when we find something unusual, the default assumption is always natural formation, and that assumption is usually correct. But what if sometimes it isn't? What if scattered throughout the geological record are genuine artifacts of intelligence, so old and so weathered that they've been classified as natural curiosities? What if the reason we haven't found clear evidence of ancient civilizations is that we've been looking at that evidence for decades and filing it under unexplained natural phenomena? This Sing Wild Theories, or ABEN, isn't about embracdoning scientific skepticism. It's about recognizing that our interpretation of unusual finds is always filtered through our expectations about what's possible. We see what we're prepared to see, and we're not really prepared to see evidence of intelligence that predates our own species by millions of years. Consider how long it took archaeology to recognize some genuinely ancient human artifacts, stone tools that were initially dismissed as naturally fractured rocks, cave paintings that were thought to be mineral stains, burial sites that were interpreted as random bone deposits. It often takes decades of accumulated evidence and shifting theoretical frameworks before we're able to recognize artificial patterns in ancient materials. The same interpretive challenges would apply to evidence of non-human intelligence, only magnified by the vast timescales involved. A perfectly round stone sphere might be a tool or a natural concretion. A linear arrangement of unusual minerals might indicate intelligent placement or just geological coincidence. Without context, without surrounding artifacts, without cultural frameworks to help us interpret what we're seeing, even genuine traces of ancient technology might remain invisible to us. There's also the question of what we mean by technology. We tend to think of advanced civilizations in terms of metals and machines, but intelligence doesn't have to follow that path. What if an ancient species developed biotechnology instead? What if they learned to shape living organisms the way we shape metals? What if their greatest achievements were biological rather than mechanical? Imagine a civilization that bred plants and animals with the same precision that we manufacture electronic components. They might have created living buildings that grew rather than being constructed, living tools that evolved to fit their purposes, living transportation systems that move through biological processes rather than mechanical ones. After millions of years, would we be able to distinguish their engineered organisms from naturally evolved species? This possibility becomes even more intriguing when you consider how much we still don't understand about the history of life on Earth. The fossil record is full of sudden appearances of complex organisms, evolutionary leaps that seem to happen faster than gradual natural selection would predict. Most of these rapid changes have perfectly good explanations involving environmental pressures and genetic mechanisms we're still discovering. But what if some of them don't? What if some of the puzzling features in evolutionary history represent the lasting influence of intelligence that learned to work with biological systems rather than against them? Species with unusual genetic diversity that suggests artificial selection, organisms with capabilities that seem too sophisticated for their environmental niche, evolutionary patterns that look almost intentional. Even our own DNA contains mysteries that geneticists are still trying to understand. Large sections of non-coding sequences that seem to serve no obvious function. Genetic switches that activate under conditions that no longer exist in our current environment. Molecular machinery that appears more complex than what would be needed for basic survival and reproduction. Could some of these puzzling features represent ancient genetic modifications, so old that they've become integrated into the normal functioning of life itself? Could intelligence have left its mark, not in stone or metal, but in the very code that governs how living things develop and behave? The beauty of this possibility is that it's almost impossible to test directly. Genetic modifications that occurred millions of years ago would have been subject to all the normal processes of mutation and selection. They would have been refined, altered, and integrated into natural evolutionary patterns until their artificial origins became undetectable. Yet sometimes, if you know what to look for, you can still see the seams. Geneticists occasionally find gene sequences that don't quite fit the expected patterns of natural evolution, regulatory mechanisms that seem unnecessarily complex, molecular structures that look almost engineered. Most of these apparent anomalies turn out to have natural explanations once we understand them better. But the possibility remains that some of them might be exactly what they appear to be: engineered solutions to biological problems, created by minds that understood genetic systems far better than we do now. The signature of intelligence written not in monuments or machines, but in the fundamental instructions that govern life itself. This genetic approach to technology might explain why we don't find obvious artifacts from ancient civilizations. If their primary tools were biological rather than mechanical, those tools would have evolved along with everything else. Their cities might have been living ecosystems that looked completely natural from the outside. Their transportation might have been symbiotic relationships with other species. Their communication might have been chemical or genetic rather than acoustic or visual. From our perspective, such a civilization might be completely invisible. We'd see their engineered species as natural organisms. We'd interpret their modified ecosystems as normal environmental variation. We'd miss their sophisticated technologies because we wouldn't recognize biological systems as technology at all. Even now, we're just beginning to understand how much intelligence can be embedded in living systems. Plants communicate through chemical signals. Fungi form vast underground networks that share information across enormous distances. Bacterial colonies solve complex problems through collective behavior that seems to show planning and coordination. What we call natural intelligence might actually be far more sophisticated than we realize. And if biological systems can already display these kinds of complex behaviors without any artificial modification, imagine what they might be capable of with a little intelligent guidance. An ancient civilization that mastered biotechnology might have enhanced these natural information processing systems, creating biological computers that operated through biochemical processes rather than electronic ones. They might have developed living memory storage systems that preserved information in genetic code rather than written records. They might have built communication networks that operated through modified organisms distributed across entire continents. All of these technologies would be completely sustainable, requiring no mining, no industrial processes, no artificial materials that would leave obvious traces in the geological record. And after the civilization that created them disappeared, these biological technologies would continue to function and evolve, gradually becoming indistinguishable from natural systems. The more you think about this possibility, the more you realize how many apparently natural phenomena might actually have artificial origins. Unusual plant distributions that seem too organized to be random, animal migration patterns that don't quite match environmental pressures, ecosystem relationships that appear more cooperative and coordinated than typical predator-prey dynamics would suggest. Even the global systems that regulate Earth's climate and atmospheric composition might bear the subtle influence of ancient biological engineering. The complex feedback loops that maintain oxygen levels, the carbon cycle processes that prevent runaway greenhouse effects, the ocean circulation patterns that distribute heat around the planet. These systems are so perfectly balanced, so precisely tuned to support complex life, that some scientists have wondered whether they might be more than just natural coincidence. This isn't to suggest that Earth's biosphere was artificially designed, but rather that it might have been gently guided by intelligence that understood how to work with natural processes, rather than replacing them. Small modifications that nudged biological systems toward greater stability and complexity. Subtle interventions that helped life navigate evolutionary challenges that might otherwise have led to extinction. If such guidance occurred millions of years ago, its effects would now be completely integrated into what we consider the normal functioning of the planet. We'd see the enhanced stability and complexity as natural features of Earth's biosphere, never suspecting that they might represent the lasting legacy of minds that learned to think on geological timescales. Perhaps the most sophisticated technology isn't about controlling nature, but about collaborating with it, about understanding natural systems so deeply that you can enhance their capabilities without disrupting their fundamental patterns, about working with the grain of biological and geological processes rather than against them. From this perspective, the absence of obvious technological artifacts wouldn't indicate the absence of ancient intelligence. It might indicate intelligence so advanced, so integrated with natural systems, that its achievements became invisible by becoming indistinguishable from the normal functioning of life itself. As sleep begins to pull you deeper into its own natural rhythms, consider the possibility that intelligence might be far more common and far more subtle than we imagine. That consciousness might emerge regularly throughout Earth's history, not always in forms that build monuments or leave obvious traces, but in ways that enhance and guide the ongoing experiment of life itself. Maybe the reason we feel so connected to the natural world isn't just because we evolved within it, but because it bears the gentle influence of countless minds that came before us. Minds that learned to think like ecosystems, to plan like geological processes, to create like evolution itself. Minds that understood that the most lasting technologies are the ones that become indistinguishable from nature. The boundary between natural and artificial might be far blurrier than we assume. And maybe that's exactly how the most sophisticated intelligence would choose to work, leaving behind not monuments to their own cleverness, but a world that's slightly more stable, more beautiful, slightly more capable of supporting the consciousness that continues to emerge from the endless creativity of life itself. Sleep now, knowing interconnected, something that you're part of, something vast and that might hold more intelligence and intention than we've ever dared to imagine. Dream of biological computers growing in ancient forests, of genetic libraries preserved in the DNA of creatures we see every day, of technologies so elegant they became invisible by becoming alive. So here we are, at the quiet end of our journey through deep time, having wandered through millions of years of possibility and mystery. We've explored the chemical fingerprints that civilizations leave behind, the way oceans swallow entire histories, the stubborn silence of rocks that might hold secrets we'll never decode. We've imagined intelligence that worked with biology rather than against it, minds that chose invisibility over monuments, technologies so sophisticated they became indistinguishable from nature itself. Maybe we are the first. Maybe consciousness is so rare and precious that it took 4.5 billion years of planetary evolution to produce even one species capable of asking these questions. Maybe every time we look up at the stars and wonder if we're alone, we're experiencing something that has never happened before on this particular world. Or maybe intelligence blooms and fades like seasons we're too brief to notice. Maybe the Earth has been home to countless experiments in consciousness, each one finding its own way to think and create and wonder, each one eventually returning to the patient recycling systems of geology and time. Maybe we're not the first chapter in the story of terrestrial intelligence, but simply the latest one we happen to be able to read. The beautiful thing about not knowing is that it leaves room for wonder. It keeps the universe a little larger than our current understanding, a little more mysterious than our instruments can measure. And maybe that's exactly as it should be. Maybe the questions that help us fall asleep are more valuable than the answers that might keep us awake. As you drift off tonight, wherever you are in this vast world, you're participating in something that connects you to the deepest currents of cosmic time. Your curiosity, your capacity for wonder, your ability to imagine minds that might have gazed at these same stars millions of years before you were born. Whether you're the first to do this or the latest in a long line of dreamers, you're here now, conscious now, part of the ongoing mystery of what it means for the universe to wake up and look at itself. Sleep well, fellow traveler through time. The Earth will keep its secrets a little longer, and tomorrow there will be new mysteries to explore, new questions to ask, new wonders to discover in this ancient, patient, endlessly surprising world we call home.